If p is a non-zero number, what value or values must be greater than p? In this problem, we have 5 possible solutions, A through E, which relate to 3 different cases, Roman numerals 1 through 3. Perhaps the easiest way to test cases 1 through 3 is to try different values for p and search for a counterexample to prove the case invalid. The number or numbers we choose for p depends on the equation of the case itself. For instance, for case 1, we have the absolute value of p. As long as we test a positive number for p and a negative number for p, that will be a sufficient test. So if p equals 8, for instance, and p also equals negative 8, both cases result in a value of positive 8 because of the absolute value bars. The question asks, what values must be greater than p? For case 1, our resulting output values are 8 and 8 from the input values of negative 8 and 8. So, using a negative value of p will result in a greater output. But this is not true for a positive value of p. The function returns the same number. So case 1 is not valid. It has to be true for all non-zero values of p. This means that if we can find just one non-zero value of p, for which the case using p is not greater than p itself, then the case is not valid. With that in mind, let's turn to case 2, the quantity p minus 1 squared. Can we find a counterexample? Is there a non-zero value of p where p would not be greater than or equal to the quantity of p minus 1 squared? Absolutely. How about p equals 1? That would result in a value of 0. So case 2 is not valid either. Case 3 is p squared minus 1/2. Again, we can use p equal 1, which results in a value of 1/2, which is not greater than p. So none of the resulting values from cases 1 through 3 can be greater than the value of p for all non-zero values of p. The answer is E.